Alright, so a quick video about DC motors. Here's a DC motor connected directly to the power supply. I'll turn it on, check it out. We've got 6 volts going to it, and RPM wise. Okay, so one of the first circuits you see out there in terms of DC motor speed control is just using a potentiometer to introduce resistance into the circuit, using it as a variable resistor, or like a rheostat, if you remember the old what are they, slot car controllers, kind of like that. And so what I'm doing here is I'm using this 100K potentiometer to control the speed of the motor, which is exactly what you'll see in another couple videos. And I think this alone, I think there's a couple problems with this, but let me demonstrate the first one. So I think if you know how potentiometers work, if I connect to there, I'm going to use it just as a variable resistor, so I'm connecting those two. And when I've got it turned all the way this way, counterclockwise, I'm basically shorting it out, and there's nominal ohms in there. And if I go, of course, if I move the wiper blade all the way around clockwise to the full position, now I've got the max, which in this case would be 100K. And so one of the things is these DC motors, actually it takes very little resistance to alter the speed of the motor. So with that said, if I go here, generally what you would want to do with a 100K potentiometer is to use the entire range of motion to control the motor. And I think you'll see what happens here is if I go all the way, so nothing's happening, I need to go almost all the way over before it even engages. And then I can control it, I can make it slow or faster, but I'm using almost none of the range of motion of the resistor. Okay, so rather than using the 100K potentiometer, you can see here I've got 100 ohm resistor. I've got it connected, and you can see nothing's happening at 100 ohms. So let me disconnect that, and we'll go all the way to the opposite end. I've got 9.7 ohm resistors. You'll see that works, spins it at a specific speed. I can go to 22. I guess what I'm getting at here is that ideally, even if you were going to do that, you would use like a 100 ohm. Now it's spinning a little slower, 22 ohms. And finally, you'd use it like a 100 ohm pot, not a 100K. But so let's see if this even works. Okay, so now you'll notice even at 46, spinning very slow. It doesn't even want to spin sometimes. Okay, so now it's stopped, but if I spin it, it'll keep it going, but the initial current necessary to get it going, can't pull it. So let me throw that. Alright, but there's a whole other reason why potentiometers are a terrible idea for this. Okay, so potentiometers then are generally used for what we'll call signal circuits instead of power circuits. And even though this is a really small motor, DC motors kind of consume a decent amount of current. And these, as all electrical components, are only rated, I think, at maybe 0.25 of a watt or maybe 0.3, I don't even know. But point being that you can easily overload your potentiometer, the resistance in there, trying to power DC motors. So there's a reason why, no one suggests this simple circuit. And so if we go ahead and, if you remember, the current is directly proportional to the voltage. So I am going to increase the voltage here real quick. And then we'll go ahead and turn it on, and let's see what happens to the potentiometer with more current. Oh, what a freaking letdown. I was hoping for smoke. I was really hoping that thing would catch fire, but you can see here with the continuity check, if I go and I short those 2 leads, I mean, it just died instantly. So you can see there's no more continuity through there. Okay, just to show that the resistance, that you can kind of control the motor via resistance in the circuit. This is the only 100K pot that I've got. But so if you see that if I start playing with this, I can really kind of control. This is a 100K pot, so it's, I've got the entire range of motion to I'm misspeaking here. If you remember, I had 46 ohms. It was pretty much dead, so I've got about half the range of motion. Okay, so the next circuit I'm attempting to show here is like the simplest possible transistor circuit. I think this is using 2N22222 transistor, if I remember right. But again, this has the advantage of routing the current through the transistor and keeping the potentiometer with low draw. So let's take a quick look at this. This is a simple transistor setup. You can see I got the multimeter attached. I've got the scope attached. We're running 5 volts. I've got, I think, a 10K pot again. And so you can see, hopefully you can see what's going on here. Controlling it via the potentiometer. You can see how the voltage is jumping. If you look around the internet, you'll see that there is one recommendation that everybody makes to this exact circuit, and we'll take a look at why right here. Okay, so in this next clip, I've got the time frame on the scope compressed, and what we're going to try to look for is what's basically a well-known phenomena with DC motors, which you should see some big negative voltage spikes. There's one, there's a second one right there, and that has to do with you know, the spinning magnets on the motor. Not to get totally derailed here, but that is that electromagnetic force that can generate those negative voltage spikes. What I'm doing here is just spinning the DC motor with a drill to show that you can, in fact, induce some of those spikes. And the solution to this is to include a diode in the circuit, which I will demonstrate here in the next section. Okay, now you'll see we've got a small diode in there. We've got the scope running. I'm going to turn on the output, and then let's see the voltage increasing, but then look at the back spikes. Let me turn it all the way up. Okay, so I think you get the picture. It using that diode can, you know, eliminate those backward voltage spikes and protect your transistor. Okay, so we looked at controlling the speed of the motor using a transistor, that 2N2222 transistor. You can also find speed circuits using the LM317 linear voltage regulator. There's quite a bit of information on that out there. Obviously, that works by controlling the voltage that the motor sees. And then finally, using the NE555, you can come up with a PWM circuit, which is the one I want to look at next. Rather than build a circuit from scratch, I will go ahead and use an out-of-the-box one I've got sitting around. Okay, so there's our little speed controller, and you can see it is an NE555. Okay, so that was a long-winded way to arrive at pulse width modulation. This is our little speed control, PWM speed control, that is equipped with that NE555. I'm going to turn the scope on, and you'll see across the top there's the PWM signal. You can see you know, vacillating between high and low. That's total high. And so what it does is it affects the effective voltage that the motor is seeing. So if I go ahead here, even though the power supply is set on 6 volts, if I apply the prongs of the voltmeter, you will see that the effective voltage there is only 3.8, even though it's bouncing, you know, in between 0 and 6. So I'd be remiss if I didn't mention duty cycle right here. So if we take this as the waveform that we're seeing on the scope, 0 and 10 volts, and then let's just say that one cycle is what we see right here. The duty cycle is, you know, it's on or high for about half the time. We'll say this is 50%, and it's off, which is low for 50% of the time. What you would see here is like a nominal voltage of 5 at the motor, you know, because it's that relation that counts. So the same. So we're using PWM in this case to alter the effective voltage at the motor on these. We'll do a separate video on these, the new 4-prong computer PC fans, which are also DC motors, and how that can use a constant voltage as well as a PWM signal on a signal pin using circuitry that's on the fan itself to control the speed of the fan, but that's a little bit more advanced than what we're trying to cover here. So that was a long-winded way of suggesting that you use PWM to control your DC motors. I didn't even get a chance to talk about the efficiency or that, but I hope you enjoyed it, and we'll try to come up with a better video on that. Thank you. Bye.